Hey, good evening, Valley Middle School. Welcome back to another G67 math video. Tonight we're going to be exploring the world of area, perimeter, surface area, and even volume using scale factor. But let's start off with our trivia question of the night. Just for fun, why do we dump salt on our icy roads? What I'm looking for is what's the science behind that idea? We're a STEM school here. Let's see if we can figure that out. All right, tonight officially we have a couple of targets here. I can use scale factor to find the perimeter and area of similar two-dimensional shapes. We've already done that. That'll be kind of a review target. But also, I can use scale factor to find the surface area and volume of similar three-dimensional shapes. Let's do this thing. All right, here's a review slide. We have this rectangle here. It has a perimeter of 12. You can see we've got 4 and 2 and 4 and 2. So we have a perimeter of 12. We are going to take and draw a new rectangle down below here, and we're going to use a scale factor of 2. How would we figure out what the perimeter would be? Well, we could draw it out and we could say that, well, if this side is 4, this side has to be 8. If this side is 2, this side has to be 4. And we can figure that out. We could figure out that that perimeter is 24. But we can also use scale factor to do it. We can take the original perimeter and we can multiply it by the scale factor. Remember, the scale factor was 2, and we would get 24 centimeters. Likewise, we could figure out the area of the new rectangle. We could take the area of the old one, which is 8. We had 4 times 2 here. And we can pop that in, our formula, and we can take that times the scale factor squared, because area is kind of a two-dimensional thing, so we're going to square it instead of just using the scale factor. So the scale factor squared. 8 times 2 squared is really 8 times 4, which is 32 centimeters squared. And that makes sense because we have 8 times 4 here. Cool, huh? So we wouldn't even needed to have drawn it. We could have used scale factor to determine the perimeter and the area. And the area, of course, makes sense because if you remember, we have 2 times 4, we have 8 units up here, but each of these units down here has 8. So we really have 4 groups of 8, or a total of 32 centimeters squared. Let's take a look at our new words, or the word odeos. So the scale factor is the first one. That's that ratio of corresponding sides in similar figures. The perimeter, distance around the outside of a shape, area, the number of square units that can be contained within a shape, or two-dimensional shape, and the volume. That's the amount of space inside a solid figure, a three-dimensional figure. So let's take a look at another example here. We have this little rectangle here, and we are going to enlarge it using a scale factor of 3 this time. So the rectangle is 1 by 3. So it has a perimeter of 8. It has an area of 3 times 1. So let's use our formula here. We pop that original perimeter of 8 in. We just multiply it by the scale factor. 8 times 3 is 24. The perimeter of the new rectangle will have a perimeter of 24 units. We can take and use the scale factor for the area too. Take and pop it in. The original area was 3. We take it times the scale factor squared. Remember, area is two-dimensional, so the scale factor squared. So we have 3 times 3 squared, or 3 times 9 is 27 units squared. And that makes sense. We can take a look at that. Here would be we would increase the width of it by 3 and the height of it by 3. And our area would be 3 times 9, or 27 units squared when we were done with that. Kind of cool. We can figure it out mathematically without drawing it. All right, let's take a look at surface area. Now, we've talked a little bit about this, finding the surface area of rectangular prisms, but let's use scale factor to find the surface area tonight. So we have this Rubik's Cube on steroids here. It's 6 by 6 by 6. So if we were to find the surface area of this, we could find 6 times 6. So this side would have 36 units squared. And there are 6 faces, so 36 units times 6 is a surface area of 216 centimeters squared. Well, how can we use the scale factor to find the surface area of this smaller Rubik's Cube? Well, our scale factor is 1/2. So let's just pop it in. We'll take the original scale factor of 216. We'll multiply it by 1/2 squared. That's right, because it's surface area, that two-dimensional thing. So we're going to use our scale factor squared. Well, 216 216 times 1/2 squared is really the same thing as 216 times 1/2 times 1/2, which is really the same as 216 times 1/4, which is really the same as 216 divided by 4, which is really the same as 54 centimeters squared. And this makes total sense because if you think about it, you have the sides here are 3 times 3, so there would be 9 centimeters squared on this side. And if you multiply that by a total of 6 faces, 9 times 6 is 54 centimeters squared. All right, cool. Let's see what we can do with volume. All right, we can use scale factor to find the volume too. Here's that Rubik's Cube again. Remember, its volume is 6 times 6 times 6, so its volume is 216 centimeters cubed as well. If you want to think about base times height, you can think about 36 times 6. You know, the base would be this first layer here of 6 by 6. Big B, we call it. Still 216 centimeters cubed, however you slice it. Get the cake reference? I thought you might like that. All right, scale factor. Our scale factor is 1/2, so how do we use that to find the volume? Well, let's pop our original volume in. We have 216 was our volume. And we're going to multiply that by the scale factor, what? The scale factor cubed. We've added a third dimension. It's a third dimension. So now we're going to use the scale factor cubed. Well, 216 times 1/2 cubed is really the same as 216 times 1/2 times 1/2 times 1/2, which is really the same as 216 times 1/8, which is really the same as 216 divided by 8, which is really the same as 27 centimeters cubed. And wait a minute, let's think about it. We know how to find volume on this guy. We can just go 3 times 3 times 3. 3 times 3 is 9, times 3 is 27. Cool, but we figured out mathematically with the scale factor. This could come in handy, folks. All right, let's take a look at another one. All right, one more. We have this rectangular prism here, and we don't even have any measurements on it. Can we use the surface area and the volume of it and scale factor to find the surface area and volume of a new rectangular prism with a scale factor of 4? Yes, we can do it. All right, let's do it. All right, so the surface area is 164 square inches. So I'm going to take that surface area, and I'm going to multiply it by the scale factor. Remember, our scale factor was 4. Our scale factor squared. So 164 times 16, 2,624 inches squared. And I didn't have to even measure anything. All right, how about the volume? Well, we'll pop the volume in. The volume of this rectangular prism up here is 120 inches cubed. So 120 times the scale factor cubed. This is really 124 times 4 times 4 times 4. So 120 times 64 is 7,680. What? You don't believe me? All right, I'll do it. Clear this baby out. 120 times 4 times 4 times 4 equals, bam, 7,680 inches cubed. You guys got to start trusting me one of these days. All right, time for you to try one. We have a rectangular prism up here. I've put the measurements down, 4 times 8 times 3 inches. But you know what? You don't even need that. Use the scale factor, which is 3, to create or to find the surface area and volume of a new rectangular prism. Go ahead and try it. I'm back. All right, let's see. The surface area. Pop that surface area in. Well, the old surface area was 136 inches. You multiply that times the scale factor squared for surface area. So that's really 136 times 9, 1,224 inches squared. How about the volume? Well, the volume of the old one was 96 inches. So 96 inches times the scale factor cubed. This is really 96 times 27, which is 2,592 inches cubed. How'd you do? You getting the hang of this? Oh, let's try a couple more. Oh, wait, the skinny first. My daughter really liked this one. I said, when you think about using the scale factor, think about the old or the original versus the new. So for perimeter, you just take the perimeter times the scale factor, and you'll get the new perimeter. You take the old area or surface area times the scale factor squared, and you'll get the new area or surface area. You take the old volume times the surface area cubed, and you'll get the new volume. See if that will help you. I took and pasted it in on the next couple of slides, and it's time for you to do a little bit of work. All right, we have this little triangle here. I want you to calculate the perimeter in the area of a new triangle with a scale factor of 5, or using the scale factor of 5. Go ahead and take a second to try that. All right, let's see how you did. All right, well, here's mine. I tried to make it as close to a scale factor of 5 as I could and still fit it on the screen. But if you take the perimeter, I found the perimeter to be 45 units. That's the original perimeter, which is 9, times the scale factor of 5 would give me 45 units. All right, the area, well, the original area was 3.9 units squared. So I took that times, I got to fix this, times 25. Stretch that out just a little bit, because that is really the scale factor squared, and you get 97.5 units squared. All right, now another thing we can talk about in some of the problems we're going to practice today is going to talk about the ratio between the new and the old. Well, let's think about it. What is the ratio between the new perimeter and the old perimeter? Well, this is 45, and this was 9. If I simplify that, that's really a 5 to 1. Think of the scale factor, 5 to 1. Well, what about the area? The area can't be 5 to 1 because look at this is 3.9 and this one is 97.5. Well, it's the scale factor squared. The ratio between the area from the new to the old one, it's 97 to 3.9. It's really 25 to 1. You follow me? We'll give you another shot at it. All right. See if you can determine the surface area and volume of a new rectangular prism created using a scale factor of 1/2. No dimensions. I'm just giving you the surface area of this rectangular prism and the volume. Go ahead and give it a shot. Yeah, I got my little cheat sheet up here to help you if you need it. All right, let's take a look. Where are my figures? Here we go. Got to slide them down. So the surface area of the old one was 440 units times 1/2 the scale factor squared. Well, that comes out to be 110 units squared. All right, how'd you do? The volume was, I'm going to struggle getting this one up here. I'm going to have to slide it just a little bit. Sorry about that. I'm going to miss a couple things here. The volume was 600 units times, there we go, I can move it down. Sorry. 600 units times 1/2 cubed, the scale factor cubed. Well, that's really 600 times 1/2 times 1/2 times 1/2, or 600 times 1/8, which is really 600 divided by 8. It's 75 units. All right, 75 units cubed. All right, so let's talk about these ratios here now. And this is really bugging me that this is messed up, but I'm sorry I can't get that up there. Maybe if I just do this a little bit longer. My 3 is still too low, but you're going to have to live with it, folks. Oh, you know I'm a perfectionist. There we go. Close enough. All right. What about the ratios? What is the surface area ratio from the new to the old? Okay, let's think about the surface area. Well, this was 110 to 440. I could simplify that and say that that's 1 to 4. What about this? What is the volume ratio from the new to the old? Volume ratio from the new to the old. Well, again, that's that scale factor cubed, or 1 to 8. So here it was 1 to 4, the scale factor squared. Here it was this, the volume was the scale factor cubed. Interesting, huh? All right, time for you to show me what you know. All right, take a look at these two figures that I barely fit on the page. What is the ratio from the old surface area to the new surface area for the figures below? What is the ratio from the old volume to the new volume for the figures below? Yeah, you're going to have to figure out what the scale factor is. Looks like I got to move this guy just a little bit here. So this one here is 3, 4, and 5. This one here, whoa, ew, everything got shifted, I guess, folks. This one here is 9, 12, and 15. All right, Time for the just for fun question. Just for fun, why do we dump salt on the roads in the winter? Well, because the freezing point of salty water is lower temperature than pure water. So scattering some salt on top of the icy road accelerates the melting process, opens the road up. Do you know that we put down more than 22 million tons of salt on our roads? That's about 137 pounds of salt for every American. Yikes. That's some salty information. That's all I got. Thanks for listening. Bye.